The SD Ruby podcast is brought to you by New Relic.
Cool, so I'm going to talk about writing JSON APIs using Sinatra and then testing it with rack test. So I'm Bensi on Twitter, GitHub, and anywhere else. I'm a freelance developer, mostly Ruby, some iOS, and kind of whatever comes along. I maintain a couple gems that you may have heard of or used, Carrier Wave and Mini Magic. Patrick actually asked me to give a talk on Carrier Wave, but it's hard to get excited about file uploads, so I decided to do something else instead. I also have been working with Etienne and Monk Dev Academy as an instructor. We're trying to do classes to teach people that are new to Rails, to Ruby, to programming, and we've finished our first class. Okay, so talk today, just kind of a general announcement. This is all just what I think. I've been writing several APIs for a lot of clients for my own projects over the past couple of years, and kind of settle on this way of doing things. That's not to say that you're doing it wrong or there aren't other ways. I'm not saying that at all. I'm very open to constructive criticism. If you have better ways of doing things, I'd honestly love to hear it. So this is really just opinions. This is not a talk about whether you should use REST or hypermedia or stuff like that. This is just picking tools to get the job done. So a couple assumptions I'm making is that you have or are building a Rails app, and it needs to add an API. We're going to build a JSON API. XML is totally doable. If you have to build a SOAP API, I got nothing for you. It assumes that testing is very important. We're going to test, essentially, I'm going to put a bunch of code on the screen that tests what we're doing. I'm actually going to run them, you'll take my word for it. I'm also, I kind of took a lot of the ideas from GitHub's API, if you're familiar with it at all. They have a pretty solid JSON API, and from talking with one of the guys who works there, they actually use Sinatra they have like 30 mounted Sinatra apps in their Rails 2.3 app. And that's what serves their latest API. So some options. This is not using Sinatra for building an API that's out there already. One thing that you can do is use respond to and respond with an existing inline in your controllers. This is one way to do things. This is kind of when Rails first came on the scene, it celebrated that it could kind of do this for you automatically, where it would detect your content type and serve XML or HTML or JSON in the same controller. Another option, Rails API is very new. It's kind of a dumbed down version of Rails that loads only what is needed to run an API, and that works with a gem called active model serializers that Jose Valim and Yehuda Katz came up with. And that basically serializes your active record objects in their own class just for serialization. So it kind of, it does just that. Another option is using Rails, but having separate controllers just for your API. So you might have an API namespace, and with an API controller, and then all your other API controllers would inherit from that parent API controller. In that case, you would probably use something like JBuilder which is DHH's kind of JSON view builder, or there's another one called Rabble, which is very similar. It's kind of its own syntax for building JSON. Another one is Grape. Grape is built by one of the guys at Intridia, now several guys at Intridia. It's actually very similar to Sinatra. It's a Sinatra-like DSL that's just for building APIs. I tried it back in the day, and it had a lot of test failures, and it handled error. Error handling was rough, and so I ended up walking away. I've heard it's a lot better now, but I haven't tried it. So that's kind of an overview of what's out there. They're all perfectly viable options, except for inline respond to. If you're building an API and you actually plan to maintain it, I would highly recommend that you look at anything else other than cluttering one controller with your HTML, your JS, and your JSON, if that's what it is, or XML. It's impossible to maintain. So if you have the choice, please just don't do that. All right, so Rails really encourages MVC, and most of the time this is just fine. The separate Rails controller, JBuilder, with your model, that's kind of where this really shows, and so that's the DHH view that everything should be MVC. I totally understand that argument. I get it, but I don't personally think of JSON as a view. I think it's just another way of. It's still data to me. You know, it's just a simple hash or an array of hashes typically. So having an actual view file for JSON just doesn't really make a whole lot of sense to me. So I think it belongs in more of a controller space. So you just have your model, your data, and a way of rendering it out. So since it's just simple hashes in the end, I'm going to show you the way that I start writing an API every time. Can you guys see this somewhat?
Yeah, that's good.
All right, cool. So at the bottom, there's a gist that has all the code from this talk just in one monster gist. But if it's tough to read anything, or I go too fast, or you want to refer to something. So what I'm doing here, and this is in every single model where I'm exposing data via an API, I make 3 hashes. I make a base hash, a full hash, and an authenticated hash. The base hash is going to be just the basics that you need to render that object as part of a collection. So it's going to be stuff that preferably does not load associations. Or if it does, very minimal, because we want things to be fast. So if we're going to load 50 of these or 100 of these, depending on what you allow in your pagination, you want to make sure that it's quick. The full hash is the base hash merged with whatever you want. So it could be association data or anything else. And then the authenticated hash is the full hash merged with anything that's secure or secret to that user or the owner of whatever object. So that way we kind of have this template for always using the same type of hash across objects. Here's another example where we have an event that belongs to a user. The base hash is very simple. The full hash actually calls the user's API base hash. So that way we can kind of generate this very obvious template of associations and calling the same methods across all different objects. Because these are just simple hashes too, you just test them like regular objects. There's nothing special. You're not, it's just another unit test, which is very, very convenient. And I didn't show the authenticated hash there just because, just for the sake of space. And actually though, even if my authenticated hash is the same as my full hash, I still add that method there. That way, when I'm actually working in API land, I don't have to think about, does that model have anything different for an authenticated hash? That way, later on, if I want to go back and add something that should be there for the authenticated owner of an event, it'll just be there. Okay, so now getting into Sinatra. Sinatra is just a Ruby DSL for creating web apps. It's pretty simple. You specify your request method followed by the route that you want the route you want it to use. So you could say, so this would hit the root of a web app, and you return the response body as a string. That's at its simplest. It allows you to specify before and after callbacks. You can set custom headers, custom status codes, any content type. So it's very simple, but it really is very powerful. We're gonna test everything with rack tests. It's what it sounds like. It's just a simple testing API for rack apps. It'll work right alongside with RSpec or whatever else you're using. So don't feel like you have to rip something out just to add this. Another little piece, I really try and keep my dependencies to a minimum. So it's really just these three. Sinatra, rack tests, and then Sinatra namespace is just a little add-on to Sinatra that's part of the Sinatra contrib. It's an extension of core. It's maintained by the Sinatra guys, but it just allows you to easily add some namespacing in your file. So you can see I have a get for the root, a get for /v1, and then a namespace for /v1. So then, excuse me, anything within /v1, basically I can set before and after callbacks within a namespace, and those will run before each and everything in there, and everything inside the namespace is within /v1. So this makes it nice and easy to version your APIs, which I also highly recommend. There are a couple ways to version your APIs. This is one way. This means that your URLs will have to change when you go to v2, which for some may be undesirable, but kind of just the way it is. There are plenty of production APIs out there that version by number, or Amazon uses dates, so they just you just specify the date of their API followed by the API endpoint, and you get an older or a newer API. However you want to do it is fine. The GitHub guys actually they add, or they let you set a custom accept header that specifies the version. So there's a default version that you get if you don't specify the accept header, but if you want their beta API, you just set that accept header and you'll get whatever new feature they've added back. So there's definitely some benefits there. I totally want to try it out. I just haven't yet, and I mean, I've been using this, and it's fine for most cases. But that seems like a cool idea, to be able to not change your URL schemes, and you can just kind of add endpoints whenever you want without really worrying too much about it. So just kind of covering a little bit of what this does here. If you look in that gist, I'm not showing it here, but here's a JSON Helper method that just takes a Ruby hash, makes it pretty printed JSON, so it's nice and indented and all that, and writes it to a string. And so the last, as long as your Sinatra methods return a string, that's going to be your request body, your response body, sorry. And by default, the status code is 200, which is just HTTP's okay status code. So under my /me, there's also, I have an authenticate method. The assumption here is that you've authenticated, so you know that by the time you get, if that were to fail, it would return a probably a 401 unauthorized, and otherwise JSON and then call the current user and get their API authenticated hash because you know it's them. So this is what testing it looks like. I cut off the browser object that you actually get back when you create that browser object. The details of it are in the gist. So we're just doing a quick test to make sure that when we call a get to the root, it should 200 with a hash with a message that says welcome to the API. That should 200 is also in my gist. None of this is built in. So these are all, except for the browser object is what you get from rack test. The should 200 is just a assertion that I added to a bunch of, I made a bunch of macros that should 200, should 204, should 404, bunch of status codes that just to make my life a little bit easier, and that response content type should be JSON. So that's really it for.
Is this rack test we're looking at here?
So yes. So where the browser, where it says let browser, so that object that gets created there, the ... is like, it's a lot longer, but it's in that gist. So that's what rack test is giving you, and you can do this browser.get, browser.post, browser.delete, or put with your parameters and your JSON body, and then you'll get a response. And we're gonna, I'll cover that shortly. So error handling is actually the reason that I originally got away from using Rails to handle APIs. I still don't have a clue how to always respond to errors in a friendly way when this is very specific, but if you run through the Rails routing layer and you don't get a match, you get an action controller routing error exception. There's no real way to capture that error with any context just to a namespace of your API. So what ends up happening is you have your API, when all is well, it's returning JSON, everything's happy. When things go wrong, it spits back, you get a 500 error, or you get an action controller routing error, it's going to spit back HTML at you. It's going to spit back an HTML 404 error. And to this day, I haven't found a good workaround for this. If you have one, I would love to know. Actually, Jimmy Quadra just posted on Twitter a couple hours ago a very, very similar question, which I thought was kind of weird that he asked that today, but he seems he can't really figure it out either. So anyway, we're going to mount this Sinatra app in a Rails app, and so it allows us to do this. So when the Rails router hits, the mounted app at /API, any request goes into that into this app. So at the end of this app, we're going to make sure that nothing gets past it. So if you're in the API namespace, you will never end up back in the Rails router. I added these get, it's a get and a /star, post /star. So it's a catch-all for every possible route within this API's namespace. And then we're going to call a method just halt with 404 not found, which just does this. Sinatra has a lovely method called halt. It takes the HTTP status code as an integer, followed by a response body, and it just stops there. So whatever else may be in your Sinatra methods or your get or your post, it's just going to skip it. It's just going to halt. It's going to stop exactly where you're at, return this status code, and return that body. So anytime we hit anything that's not found, no matter what HTTP verb we're using, we're always going to 404. So this makes your API really consistent. So that way when some third party is using your API, they don't do a post and misspell something and end up running through the Rails routing layer and ending up getting a bunch of HTML spit back to their JSON parser, which is going to choke on it, or if they're using curl to test it, it's just going to fill up 1,000 lines of terminal space. So it's just a much friendlier way of handling errors. So just a quick test here, just testing that anything at the root, any subfolders of the root should all just 404 if they're not. And they should be a JSON content type, which means they're not running through Rails' stack and spitting HTML. A bunch of other halts. So these are also just helpers that I added to my little macros file. Handling bad requests. So if JSON is not parsable, if the passwords are username or password's wrong, we return 401. If 403, I'm trying to remember what specific thing I would use that for. Anyway, and then halt with 500. I shorten this just for the sake of the slide. You probably don't want to actually serve your error message out via JSON, but I'm just showing that you can do that. You can gracefully respond with a 500. What I actually do here is in the gist, you just add an if Rails end is production. Just say something went wrong, we're looking into it, else show this message. So that way in development, you'll actually see your exceptions come back, if it coming through your test or whatever, you'll see the actual error instead of unhelpful, useless sentence that you added. Okay, so in addition to halt, Sinatra also comes with a method called error, which is how you actually capture and respond to real exceptions that get raised. So if an active record not found happens, you want to do what? Well, we made a method. Let's just halt with 404 not found. We render JSON to say it wasn't found. Active record invalid. That's what happens if you try and submit a form in Rails. You get back a 422 with all your validation errors. And actually in the halt with 422 unprocessable entity, you'll actually get back friendly looking errors in JSON format. Delete restriction error probably shouldn't be a 400, but whatever. Multi-JSON decode error, that's a 400 because we had problems parsing the JSON. And then the very last one is our catch-all for errors, and this example, I'm using exceptional to capture errors. So this way we can push our exception to exceptional and then just halt with a 500 and say, so the client will see we've heard about the error and we're working on it, or whatever it is you put. Don't ever intentionally raise a 500. That tells people that the problem is on the server side and it'll be fixed when you get around to it. If you're intentionally raising a 500, they're going to think you're going to fix it and you have no intention of fixing it. So what you want to do is any common error that you know is going to, or any common exception that you know is going to be raised by your application, you want to add that here and respond accordingly. Okay, so now that we've kind of covered all the side stuff, we're going to actually add some useful endpoints. In this case, we are going to do a GET request, and similar to the Rails router, if you want a dynamic field, you put a colon in front of it, and you have access to that symbol in the params hash. So in this case, we're calling user.find. If that find fails, it's going to raise an active record not found, and it's going to halt with a 404. We'll get to the paginate stuff in a bit. But so all that's doing is returning a JSON array of event API base hashes. The test would look like this. Create a user object, create an event object, do a get to that user's events endpoint on the API, and it should 200 with an array containing that events API base hash. If you created more, obviously it would have more in there. So just a kind of another little detour. Pagination can kind of be a pain with APIs, just because the correct way to do it is adding this really bizarre header to you add the link header to your responses. This is obviously a very shortened version. If you look at the gist, there's that add pagination headers is a nice fun method that takes care of all that. But the idea is that it's just going to add a link header that adds the next, previous, first, and last pages. It actually sends full URLs so that whoever fetches this current collection knows, okay, now I can pull from any one of these and it'll be the next in the batch. This is also assuming that we're using active record, obviously, and that we're working with a relation object using will paginate. A couple more endpoints here. If we're creating an event, so we're doing current user.events.create. Since we're using the bang method of create, it will raise an exception if the parse request body, which is another helper, is invalid. Parse request body will raise a JSON, a 400 bad request if the JSON is invalid. Otherwise, we're going to set the status to a 201, which is created, and we're going to send back the events API authenticated hash, and we're done. We want to update an event, very similar to the Rails routing table. We just do /events /:event ID. Similarly, we're finding it. It'll raise an exception if it can't be found. Update attributes using the bang method there so that we raise an exception and recover from it. You get the idea. Deleting things, you don't return anything, or you don't return a body, you just return a 204, no content. And yeah, that's pretty much it. Testing that, this is what that looks like. There's an authorized method, or something like an authorized method on rack test. I might have my own method that is similar to that, but not quite, that I'm using here. But it lets you set HTTP basic authentication. It assumes you're using that. You can obviously implement your own. But here we're just testing that a post to that endpoint with a name and a date, it should 201, so it should return it should have the status code of 201. The number in the database should be 1. And the last response body, which is something provided by rack test, should equal that user's first event's API authenticated hash. Just one more test here to make sure that validation is working correctly. If we post it with an empty JSON body, or with just an empty hash as a JSON body, it will 422, which is unprocessable. So once you're done, this is actually the only code that you need to mount it to your Rails app. You mount the class that you have all your endpoints in and then so this would be, if your app is myapp.com, this would put it at myapp.com/API. And any request to that, as long as there's nothing higher in your Rails routing table that would supersede this, everything will go to this endpoint. That's the game. That's it. Any questions?
Lindsay, what was the motivation? Sorry, I'm using the mic. But it is. We're using a wireless mic that we just got, and did you leave the? There you go. Thanks. So we're going to record all the questions. What was the motivation to add an API to your Rails app? Is it simply to serve up everything in the app, all the models and everything as JSON? And if so, what were you serving it to?
It's been various things in my own little projects. It's been a lot of Ruby motion, so writing iOS apps that talk to a JSON API. That's the primary, in my personal projects, that's been the primary thing. In other projects, they say we want an API because we want third parties to be able to create content without logging, they want to do it programmatically. The first time I did this was actually for a job board where it's a nonprofit and they take it's like 2,500 jobs a day or something like that. So those are all coming from job aggregators that wanted to push jobs through without typing them in by hand. Yeah.
Maybe that's a question.
Yeah, just a question about the serialization strategy that
Sure.
you're using with the hashes inside the model. We have an app that has an API embedded within it. Right now we're using respond to, respond with. It's become a huge mess. So we're sort of starting the process of trying to figure out what to do next. I certainly like the idea of the mounted Sinatra app. But on the serialization side, have you tried, or do you think it's possible to sort of combine the active model serializer stuff
Absolutely.
with the Sinatra?
Absolutely. I'm not sure how tied. The last I checked, it's totally possible because all active model serializers is a object that exposes some methods. So instead of calling API base hash on an event, you'd call event serializer.new with that event object and then dot serialization hash or whatever it is.
Okay.
Yeah. So as far as I know,
not as magic as using it in the Rails context. You almost don't even have to know the serializer is there. You can sort of get it for free.
Yeah. That's what I don't like about it though, because
Yeah.
I feel like you're exposing your data. This is your very sensitive data, and I feel like the defaults are always like just let everything out there, and it doesn't encourage you to test the hash that you're actually exposing.
The thing that is attractive to me about it is sort of decoupling the serialization logic from the model. So
yeah, I get that. I haven't had a complicated enough model yet to feel like I really need a whole other object.
yeah.
I mean, not that objects are expensive, just, I don't know, it's just another unit, or it's another 3 unit test.
Right. Okay, thank you.
Any other questions?
I'm wondering if when you're testing, if you ever get frustrated with sort of, I always feel that when I try and test JSON endpoints, it's just sort of clunky and it never feels like it's really easy to write the test like the way I'm wanting it. I'm wondering if you ever feel that way.
So I felt that because it's just a hash or an array of hashes that, and given that with Ruby 1.9 you don't have to deal with sorting issues and stuff like that, when you do a equality check between a parsed JSON object and your Ruby object, they match.
It's funny you say that because the sorting is one of the things where
What's that?
sorting is just a
Yeah, exactly. Oh, totally. And with Ruby 1.8, it's like, you really never know what you're going to get. So, thankfully, I haven't really felt that. It's been good. Cool.
Anybody
Thanks.
else? Aaron, no Postgres questions? All right. Thanks, Betsy.
Thank you.